I'm addressing a smart stick system using Arduino and smartphone app, right? So basically, the inspiration for the project came from a very unique problem that one of our student was facing. Right. So the main problem was that the student's granddad had partial blindness. In old age, we know it is a very common problem that people tend to lose their vision, their eyesight slightly, and hence he was movement restricted, in the sense that he was not allowed to move along on his own on the outside, right? So basically the target of the student, we have a set of students, and I'll share with you the names of the students also and the link for the project also. He wanted to ensure that his granddad's daily morning walk continues in the nearby vicinity, and that too personally, without support of anyone else. If you happen to go to the park, or maybe if you are walking in the morning, you may see often that grandchildren or maybe your parents accompany your grandparents for such kind of in case the person is suffering from this kind of a problem, right? So basically he shared this problem with me. So basically we wanted to address the problem, and we wanted to build it up in such a manner that he could reach out to his front yard, backyard, an approximate distance of 150 meters or so, which he could walk around on his own with this smart stick only. Supposing he is having a smart stick, he can use it and he can walk for nominal distance. We may not permit him for a very large distance, but this was the basic idea, the inspiration behind the project. And basically what you are looking at is the smart stick using Arduino Uno, aiding the visually impaired, right? So these are the name of the students: Dhruvin Patel, Harshit Patel, Hiren Patel, and Neerav Patel. These four students had worked under my guidance and tried to work out this smart stick, using Arduino Uno. Let us see further details of the same. Right. Blindness, we know, is a rampant disease that needs support system to overcome daily setbacks. This is a completely different kind of illness that people suffer from generally in old age, or due to maybe accident or so. Their daily life activities are affected, and most importantly their going out is restricted, and we wanted to address slightly this problem of going out, and so we came up with this project. Right. Now if you look into the system, we have the following requirements. These are the list of components. We have a development board, that is Arduino Uno, ultrasonic transceivers, three numbers, right? SNR 1, 2, and 3. We have used some buzzers and vibrators. Now, the purpose of the buzzer and vibrator is to ensure that if it is buzzing, if it is vibrating, it is a slight distance, some obstacle is at a little distance, and also another one to ensure that we are very close to our obstacle, right? So two types of options were thought about. Moreover, there is a toggle switch. Now in case the person is accompanied by someone else, then you don't need the smart stick to use its power and batteries and the Arduino, because you already have someone accompanying you, right? So in that case, you do not need all this support. You have a switch, you switch it off, which is an indication that the system will be stopping, and you can now move with your helper or family member who is moving along with you. So that was the idea behind putting up a toggle switch, a simple toggle switch, right? It is a 5-volt DC power supply, which is also sufficient to run the Arduino. And there are 3 ultrasonic sensors, which require approximately 3.3 volts of supply. Basically, our innovation comes in the part that how much distance we wanted to target, right? And in what angle. Basically, that was more important. important. You can see this is the circuit diagram of the entire setup, and you can see there are three ultrasonic detectors. This is the symbol for ultrasonic detectors, and this circuit diagram is made using fritzing, right? So we have this kind of an approach available. We have a buzzer and a vibrating motor attached here and a 9-volt battery. Since it is battery operated, hence we kept an option of the toggle switch open. So if we don't need it, we don't use it. So we have got three detectors, three ultrasonic detectors, and the UNO and a buzzer and a motor, right? Fine. Now, what comes up next? What comes up next is where to position it. At what distance should we position it so that we can cover maximum obstacles? Now, obstacles could be something, maybe a stone, a stepping stone, or some stairs, or some steps, or something like that. So we thought that 3 meter is a good average to give us an estimate that up to 3 meters it should be able to scan, right? And there are three ultrasonic detectors in order to take care of three directions, right? Front, side, left side, right side, right? So it has been placed in that manner so that it covers all the three directions, right? Generally a person is not going to move backwards, and anyhow if he tries to do that, the person will be behind the stick, so the fourth option is not possible, right? Okay, so this is for the ultrasonic detectors. Distance of 3 meter was found to be optimal. We did a little testing, and we found that 3 meter is something that can be achieved with the help of this low cost ultrasonic detectors. If you want to achieve higher range, you will have to opt for better ultrasonic detectors with higher mechanisms. Apart from that, it was vital for us to find the angle. Now, the angle that we computed after our trial and error methods turned out to be 25 degrees. So, at an alignment of 25 degrees, if there is an obstacle lying within a range of up to 3 meters, this system can detect it very well and intimate the user about the presence or absence of an obstacle. I hope this is clear up till this point. So this is our circuit diagram. Okay. Now, piezoelectric buzzer, we have called it SND1, and vibrating motor SND2 are connected so that it can guide the user using different tones and vibrations, right? So certain tones were, trained that this tone for this activity, and vibrating means, see, because a person is visually impaired, we have to work on his or her hearing capacity and other senses except sight. So the most evident thing that we could think of was of a buzzer, right? Now the drawback with the buzzer is that when a person is moving out, let us say in the vicinity of the house, or maybe inside the society, let us say he is taking a walk, so there may be other noises also. There could be a car passing by, there could be children playing by in the street or in the park or in the garden nearby, right? So it's quite possible that the person may or may not identify the sound. It happens with old age people. That is again an additional problem, that they fail to identify certain noise. But as long as the person is holding the stick, if the stick is vibrating, then the person will definitely realize that there is an obstacle. So our purpose was dual. First, generate a sound. In case the aged person are not able to identify the sound, then we opt for a vibrating motor. When it is coming very near, we activate the motor. Once we activate the motor, what will happen is that the stick will start vibrating, and as soon as that smart stick will start vibrating, the person will realize that there is some obstacle around, and I have missed the buzzer sound, and I have come too near to the obstacle, so I need to take care, right? So this was the idea behind building up this entire stick. So far we have seen smart sticks with USD, right? Ultrasonic detectors, we have seen them very common, but adding the vibrating motor was according to me one of the innovative things that we thought of, so that we could intimate the user about the upcoming obstacle. Okay. Now we all know what happens in an ultrasonic sensor. Some ultrasonic wave is sent to the ultrasonic through the ultrasonic transmitter, and it travels through air. When it collides to an obstacle, it will get reflected back. And once it is reflected back, the receiver will be able to recognize the received signals. Right? Okay. Now it is done uh, with an intention of different distances, different delay buzzer, right? So we had the buzzer playing with different delays, right? For obstacles located on the sides and no delay for the straight ones. Now see, the thinking was like that: when a person is walking, if the obstacle is lying right in front, okay, then immediately a buzzer should sound, because it is most probable the person may step on the obstacle. But in case the obstacle is lying slightly to the left or slightly to the right, then it is slightly delayed, so that the person can realize that there is an obstacle in the vicinity but not right on the path. Okay, so supposing we put on a buzzer, the person may navigate towards the left or towards the right. In case the smart stick also, the person navigates means the smart stick also moves, right? So if that also moves in that direction and finds that the obstacle, let us say the user moved right, and the smart stick now starts a buzzer, right? So what does the old man interpret? He interprets that there is an obstacle more towards my right hand side, and hence I am not supposed to take the right hand side path. Okay, so once the stick moves right, the obstacle will be head on, right? It will be on the front side, so it will give more sound getting generated. Similarly for the other direction also, right? If the obstacle is too close, that is, we kept a limit of 0.7 meter, then the vibrating motor is also activated, right? So this is how we planned up the entire working of the smart stick with the sensor. There is something known as a echo pin of the sensor, and our calculation is only one way distance. So what we do is that distance is equals to duration divided by time divided by 29.1. So this is 29.1 is a constant that we have straight away put up in this equation, and it is derived from this calculation that is shown here. What does it say? The speed of sound is 0.0345 centimeters per microseconds, and what we did is we inverted it, so we got 29.1, and hence if we divide this entire thing by 29.1, we'll get the optimum distance for which we need to calculate. Okay, because we are using sound waves, ultrasonic detectors use sound waves, so we got this distance calculated using the capabilities of the sound waves only, right? Okay, now to distinguish between the direction of the obstacle location, the following mechanism is followed. For left and right side direction locations, the delay is 500 milliseconds, right? And for forward direction, the delay is zero. It is zero delay. It has to be emitting the sound waves at maximum priority. Fine. Okay. An additional provision of a motor that vibrates the stick is planted into the assembly for very near obstacles, and experimentation study shows us that the optimum distance post assembly turned out to be 0.7 meter. Now about the construction and the testing of this entire setup. So basically what we did, we tested our test points, hardwired the sensors on the PCB because they will be in a vertical position, so we needed a wooden chassis or cardboard or plastic mounting, if in case you are planning to do that, and it has to be spherical in shape, right? Because it has to look in all possible directions except the back sides, right? So a PCB was so designed that it could be placed in a vertical position, and the final assembled device was almost midway on the stick, right? So we have a regular stick, and to make it smart we have put an assembly somewhere middle of it, right? And from that middle, 25 degrees and 3 meter distance is the optimum value used, right? The test points and their details. Okay, TP0 3.3 volts, TP13 3.3 volts, and the waveforms that are shown here, right? Now what you see here basically are three waveforms, a set of three waveforms, which are having cases with obstacle, without obstacle. So this is a DSO output. A DSO is a digital storage oscilloscope, and we can see all these outputs here. This is a case 1, this is case 2. You can see the amplitude has changed, right? This is with obstacle, and the third one is without any obstacle. So these are the different values of this waveforms that get generated, that are received at the receiver end in the presence of an obstacle, without any obstacle, and so on. So you can have a look at all of them and have a conclusion based on this. We used these three waveforms as our reference for deciding many more factors. We made a cardboard box, plastic box with 8 circular holes on it, right? 6 of the 8 holes should be of the size of the transmitter receiver of the ultrasonic sensors, and they should be punched on the wall of the box. You can see, you choose. Now these holes are supposed to be collinear to each other. The top of the box we have kept removable, so that in case we need to access the circuit, because the circuit is vertically placed inside, the PCB is actually placed inside this hole. So let us have a look at the figure for your reference. So to begin with, this is our toggle switch, right? The switch that we are using to activate the cane, the stick. If I put it off, that means it will work as a regular stick, right? Okay. Now, next you see is a piezoelectric buzzer, right? This buzzer is kept out more towards the user, right? The switch is the first thing nearest to the user, of course, because of the choice he or she wants to make, whether he wants to use the switch or not, right? The second one is a piezoelectric buzzer, as mentioned before, and the third one you can see is a vibrating motor, right? So these three units are accessible to the user, the partially impaired person, right? Now you can see there are three sensors for white coverage. So there is one on the other side which is not so visible, slightly visible. The other one is very much visible, and the third one is on, you can see it. So if I assume that the stick is held to the front, this is the front, then this would be the right hand side, this would be the left hand side from the user end. Okay. Now this box, for our case, we have made it using cardboard. The same can be done using a plastic surface also, in order to ensure that the stick continues to work in all kind of atmospheres, right? Because cardboard is not a lasting one, but for testing it is done so. Later on, when we submitted the project at our institute, we converted it into a plastic box, right? And of course the holes are made in such diameter that the ultrasonic detector ends can be placed over there, right? So this is the figure for your reference. And we had proper mounting done. The things were kept at the proper spacing. The flow chart for reference is given here. So basically we start with the system with the toggle switch, which sends ultrasonic waves through all the three sensors, takes the input from the echo of all the sensors and saves it to three different variables, right? Next, what it does is that it checks one of this and finds that if the value is less than 1, it will check it again. If it is more than 1, it will try to find out if the distance is within zero point 0.7 meter. If it is within 0.7 meter, then what is needed is that the motor should be activated. And in case it is between 0.7, beyond zero point 0.7 and 1.4 meter, then we need to activate specific echoes only, right? Specific sound buzzers. So this is how the flow chart of the system is presented to you for understanding. The software used is Arduino version 1.6.6, and Arduino IDE is used here, right? So we have shared certain details about the this thing, the operation. We have selected certain distance criteria. You can have a look at them. Up to 1.4 meter, more than 1.4 meter, no buzzer is operating. From zero point 0.7 meter to 1.4 meter, we have a buzzer, and for distance less than zero point 0.7 meter, we have buzzer plus vibration. Right. So this is how we have worked it out. Now, what we have next is something that can inspire you to continue with the project at a other end, right? So, what are the options you can have in order to extend this project, right? The intention is this is already working and it gives good results. How can you as a user extend its capability? So the first challenge for this kind of a system is to design this smart stick for steps. Remember, if there is one step, the system can detect, but if there are a series of steps, in the sense if it is a staircase, climbing up or climbing down a staircase is going to be a different kind of scenario. Now let us just discuss it. Why so? First, because when climbing up, it is slightly easy. You can sense the upcoming obstacle, the upcoming wall. We say the step of the staircase and the rise of the staircase, right? So if I'm standing on the step, I can sense there is a little rise and I will extend my leg accordingly. uh, Equally valid for a visually impaired person, right? But while coming down, what happens? You are already at a step and you need to judge where in the next step lies, how deep is the rise, right? So at that time, your USD should be located in the correct position to identify the height of the rise. Okay, so this is one challenging problem associated with this entire setup, which you can work upon and make it versatile. Right? This is already operating. If you want to work upon it, you need to have something where you can use better options. Right? Okay. So let us now move on to your doubts, if any. These are the results, and yes, as I said before, we have the link to the DIY from EFY, which I have already shared with you while I was sharing the direct you know directly the publication that we have with electronics for you, right? Okay. uh, at this point, I would like to know if there is any query that you have. If not, then I'll move on to a portion that is slightly uh, uh, different but related to this project. Apart from that, there is one thing I would like to say, that this has got an IoT interface. Basically, there is an option of Things Speak, right? ThingsSpeak, thingspeak.com. This is a website that allows us to upload our data. So this can be interfaced. Those who want to work further or maybe want to take some inspiration from this project can probably use this option also. So we can upload certain maps based on this also, or else at least regular data. Like let us say my granddad is having a move around and he moved around for 100 meters or 150 meters or 1000 meters, right? So I can have his details uploaded the on the website. It is a third party web sharing, right? And that details I can analyze later, that okay, this is the amount of distance he has covered and this is the obstacle that he has faced. Next day another set, third day another set. That is a very good option available for IoT interface in case you are planning to do something using Arduino and using IoT. Fine. So this is a very small level of implementation, but it can be, and it was done way back in 2017, right? This is 2020. But what my suggestion is that is you can always increase and work upon these things and make it better than what we have presently done. Okay, if you want to take it up, you can actually make a version which is uh, far more robust. This was a part of design engineering project, right? Costing of the devices is probably shared somewhere on the page. I hope I am out of time now. In case there are some queries, please feel free to ask me. Else, my email ID is already available with electronics for you, and you can always contact me. So I have a set of questions available here. Shivanand Rare, give idea regarding step detection while length calculation. Okay, see, step detection itself would be subject to the step or staircases that we are addressing. I could not understand what you meant when you said wire length calculation. My wires are only limited to the handle of the stick, from the handle of the stick to my Arduino interface, right? So I have the wire calculation available for maximum 1 foot, or if in case you plan to put the Arduino very low, very near to the uh, ground, the problem that we were facing, I'm just sharing the problem that we faced, was that in monsoon weather, or maybe if there is a pothole somewhere, if there is water logged somewhere, the water may enter the system, right? So we don't want it to be spoiled by the water from outside, and hence we shifted it slightly upwards. So our wire length is very limited, and hence it probably performs better because there are no losses through the wires. uh, of course, if you want to interface it to your smartphone using Bluetooth, that is another opportunity, using wireless communication, right? That is also possible, but we did not investigate that part.